Hello, how are you? I'm Hector Perez from Dev School. Welcome to a new video in which we are going to create a game called Blazor Smack in Blazor from scratch. This game is based on the Whack-A-Mole game and is quite popular. We're going to create this game from scratch, but before that I invite you to subscribe to the channel and like this video, as this helps me to continue creating quality content later on. With that said, let's begin. I am already in Visual Studio, and to start this project, make sure to select the template called Blazor WebAssembly App Empty. If you search for it as part of the templates in Visual Studio, if you search for the term Blazor, you can see that there are other templates, for example, this one called Blazor WebAssembly App that contains a sample application. We don't want this sample application, we want a blank template. You will also be able to see a template called Blazor Server App. The one you have to select, I remind you, is this one called Blazor WebAssembly App Empty. Once that is set, let's click on Next and name this project Blazor Smack, which is the name of the demonstration. As part of the application configuration, let's select that we want to configure the application to use HTTPS and also be a progressive web application. Once we have selected those options, click on Create to create the project. Done! The project has been created. Let's quickly go to the Solution Explorer, which is this one we can see on the screen. As we want to work with a new page, as part of this project, let's right-click on this folder called Pages. Let's add a new Razor component, which seems pre-selected. And let's change the name of the component to the name of our game. For example, Blazor Smack. And something very important is to add, for example, a word like component, since if you only add Blazor Smack, which is the same name that we put on the project or the solution, you will have some kind of problem. It's important to add an additional word like component. Click on Add, and now we have this component as part of the project. Since we want this component to be not only reusable but also a page we can navigate to, we'll add the add page directive. Add a slash in quotes to indicate that it will be the main page. As this will be the main page, we can remove this other file called index.razor, which is the initial page of the template. Confirm that we want to delete this file. Now we have the page we will work with. Let's define the graphical interface as part of the page. First, create an h1 tag with the name of the application, Blazor Smack. Next, create a container for the information that will show to the user. Indicate that this div will have an associated class called InfoContainer. As part of this div containing user information, one of the first data we want to show is the score at a certain point. We'll do this with the text score. Then use a variable or field called score to keep track of the game's points. We have an error here because this variable hasn't been created yet. We'll create it later. Duplicate this tag, and the second piece of information we want to show is the remaining time. We will handle this time through a field called current time. Once again, we paste this label and indicate that we do not want text as part of this label, but only the handling of a variable called message. The idea is to display information to the user and manipulate that data from the code behind through these fields. Now we're going to create each of these fields. To create them, we have to do it from this section called Add Code. We could declare the variables here without any problem. But on this occasion, I will create a file or a C# class to handle all this information and the game logic from the code behind. I will go back to the Solution Explorer. Within the same folder called Pages, which is where the component we have created is located, I will create a new class. This class will have the same name that we have assigned to the component, that is, Blazor Smack component. Okay, we now have our class created. However, you can see that we have an error. The error is telling us that this class already exists somewhere else, And that's what the component we created earlier is called, which is this Blazor smack component. To solve this problem, we have to add a keyword called partial, which allows working with multiple files that have the same class name, so that in the end all the files are joined together and compiled as if it were the same class. So with this, we can now start defining each of the fields that we will use throughout the game. For example, the first field will be named score, which we will initialize with 0. We will also create a second integer field called current time equal to 10. The purpose of this field, current time, is to specify the duration of the game. We can assign a larger number, but for testing purposes I will assign a value of 10. I will also declare a third field called hit position. The purpose of this field is to identify which square the mole appears in at a certain moment. We will also create a string variable called message with the purpose of displaying some kind of message to the user at a certain moment. Finally, one last field called game speed equal to 1000, for example. The purpose of this field is to control how quickly the figure appears as part of the game. Now that we have created our partial class, where we will handle the game logic, let's quickly return to the page. After this section, which contains the game information, we will create the div, in which all the game logic will be drawn, meaning where the main board will be drawn. To do this, we will assign a class called board. We can test the game to ensure everything works correctly. Great! You can now see the information or the container with the game information here. Also, if we inspect the visual elements, you can appreciate that we have an app tag in the DOM tree. We have a main tag, and within it, we have each of the elements we have created so far, including this div with the board class. Let's add some styles to this class called board. To be able to see it visually, we return to Visual Studio. As part of the Solution Explorer, we have a folder called www.root, where we have a folder called CSS, and finally a file called app.css, where we can add the styles of our application. We're going to create the style for the class called board. We will indicate that we want to align the content in a centered way and use a flex display. This is because we're going to have each of the squares as part of this board class. We will also indicate that we want a flex flow equal to row wrap, so that the elements, once the limit of this container is reached, move to the next row in this case, and have that row format. Then a height equal to 600 pixels, a justify content equal to center, and finally a width of 600 pixels as well. To be able to visualize this element as part of the graphical interface, we will add a border of 1 pixel width with a solid black. Let's test the application again, and we can now see the container where the main game will appear. Let's center the content. To do this, we will modify the main element, which I showed you earlier as part of the DOM tree. After this element that we have defined in the app.css file, we will indicate that we want to add some properties to the main element. Let's indicate that we want a centered alignment and a flex display again. A flex flow equal to column wrap. Since we want the elements to appear from the content, all the content that is from the page itself to appear in a container format. From the page itself, they appear in a column format. That is, first the title, in a second row the game information appears, and then in another row the main board. We will also indicate that we want to justify the content in a centered way, and also a min height equal to 100 HV. With those changes we have made, if we return to the game page, we will be able to see all the content centered, according to the specifications. Later on, we will focus on adding a bit of design to this board. For now, let's focus only on the main functionality of the game. Once we have added these styles, we will add a new component called square. And we will do this because we want different squares to appear as part of the board where these moles appear. And we want to control at a certain moment in which position it is being hit at a certain moment, and also in which position the mole should or should not appear. That's why we're going to create a component to handle this in a simple way. So we will go to the Solution Explorer again, and we will create a new folder called Components. And as part of the folder, we also add a new razor component, which we will call Square. Okay, we already have this code, which is the component code. But we also need to add a model associated with this component to specify which properties we will be able to manipulate as part of the component. Let's go back to the Solution Explorer, right-click, and add a new folder called Models. Inside the Models folder, we create a class in which we will add different properties. This class will be called, for example, Square Model. We now have this Square Model class here. The first property we are interested in adding is a private Boolean property called isShown, which will be associated with the property. Later, we will declare an integer property called ID. The purpose of this property is to be able to know which is, or to distinguish each of the squares that appear as part of the board, so that each of these squares is unique and that we can identify them at a certain moment. We will also add a second property of type string called style, with the purpose of being able to manipulate certain styles of each of these components as we need it. We will need a last property Boolean type called isShown, to which this field called isShown will be associated. As part of this property, we will indicate a get to return the value of isShown. We will also specify a set to perform some actions. The first thing we will do is assign the value of the isShown field according to the set we are performing. It is very important here to perform some checks. If isShown has a true value, then we will modify this same property called style, or add a new style to this component through the use of this style property. If this property has a true value, we add this style to the component. Otherwise, we remove it through the disappearance of the style. In this way, we allow working only with properties, simply telling it isShown is equal to true or false, and modifying this style directly. With the created model, called Square Model, we return to the Square component and can complete it. Instead of an H3 element, we work with a div. We assign a class that is equal to Square. We define this class in the style file, and it will be a class that affects all the squares that are part of the board. Additionally, we want to work with a model called Square Model, which we defined earlier, and specifically with the property called style. At this moment, we have a problem, because we have not closed the tag. We have closed it now, but you can also see that we have an error telling us that this model does not exist in the current context. To be able to use it, we go to the file called imports.razor and indicate that we want to use Blazor smack.models, which is the namespace where the models we have created for our application are located. If we return to the Square component, you can see that we no longer have this problem we had before. However, we have a problem that indicates that there is no reference for what we are declaring. This is happening because we have not created a property as part of this file. We do not have a reference, a current instance of Square Model. We can solve this by going to the section of this code. Let's declare a property of type Square Model, called Square Model. This reference that we are creating as part of a property is the one we will use to modify the class of this component. Remember that this style will be automatically modified when we work with the property. This property that we defined earlier called isShown. To add some interactivity to this component called Square, we are also going to indicate that we want to work with an event called onMouseUp, which will allow us to detect when the mouse cursor or when this mouse button is pressed. We're going to associate this event with a method called validateHit that we have not yet declared. You can see that we already have an error here indicating that this method we are associating does not exist. As part of the code, we're going to indicate that we want to create this method called validateHit, which is the method that will be executed when this event is triggered as part of the graphical interface. What do we want to do when one of the components is pressed? Notify the main component, which is the game component, in order to perform some kind of action on that game logic that is currently running. But in order to communicate with this external component from the Square component, we will have to use an event callback. Let's declare it through public event callback on mouse up. It can be any name you want. We have it ready. Simply, when this component or each of the components as part of the graphical interface is pressed, we will indicate that this event is triggered through onMouseUp.invokeAsync. We will launch a new instance of event args. This allows us to link this component with the main game component, so that the main game component can see each of these properties that we have defined and modify them as needed. We must add an attribute called parameter. The purpose is that we can work with these properties from outside. We will add this attribute called parameter so that it can also be worked with externally with this event that we are defining here. We will see later why. For now, we have our component called square.razor ready. I save all the changes, close the files that we are not currently using, and return to the business logic of the Blazor SMAC component. That is where we have defined this set of fields to be able to work with the main graphical interface. After this definition of the different variables, I will create a property that is a list of square models. This list will contain the information of each of the squares that we want to display as part of the graphical interface. We will call this property squares, which is equal to a new listing of square models. Next, we will create a constructor for our component. What I will do here is, through a for loop, indicating int I is equal to 0, I is less than 9, I++. What I'm going to do here is add or create a new reference to a square model, specifying that the ID of each of these square models will be equal to the value of the current iteration cycle. The purpose of this is to give a unique ID to each of the squares that appear in the game. In this way, we now have a list with different graphical elements or with different squares, or just that reference to the class, not the component. To create the components, I will go back to the graphical interface section, that is, where we have the HTML code. And as part of this div that has the board class associated, I will use a for each loop. I will indicate for var s in squares. Remember that squares is the property we have in the code behind that holds the references to the models of each of the squares. Here is where we will actually use the square reference. We could use the full name, that is, blazorsmac.components.square, or remove this and use a using directly at the top of the file. We have it here. We can be creating each of the components visually because we are basically validating that we are using each of the values in the list. And we can indicate that square model will be equal to S. With this, we are directly associating which is the square model directly in the component through this instance of S, that is, remember, going through each of the elements in the list of squares. If we start running the application at this time, if we inspect the visual elements, you can see that each of the div elements is being created according to the list or the list of square models components specified earlier. However, we cannot see anything visually yet because we have not applied a style to each of these square elements. Let's apply a style to them. To do this, we will go to the app.css file. I will stop the execution of the application since to be able to visualize the mole that will be part of the game, we have to create a new folder within the www.root folder. Here, I will create a new folder called, for example, img, and where I will import an image. I have already added this image called angry.png, which is the one we will use as part of the video game. Once we have added this file, I will define a style called mole, which basically uses this image that we have imported. We can drag this image, and with this, the background image property is automatically created, creating a reference to the image directly. We will also indicate a background size equal to cover. We will also add a style to modify each of the squares, that is, we add the style square. We will indicate a width equal to 180 pixels and a height of 180 pixels as well, with a margin of 10 pixels. With this, we will visualize the application again. Okay, we already have the visual part of the game here. I will modify or add an additional property as part of the board, which is the container or the board. I will add the background color property equal to, for example, E6, E6, E6. I save the changes and return to the board. To visualize each of the squares, I'm going to go back to the square, to this square style. I'm also going to add a background color, but this time the color will be white. I save the changes, and now you can see each of the squares correctly. Now, this style that we added for the mole, what's going to happen is that I will quickly go to the DOM tree. I'm going to head to the board section. Notice what will happen. When I want a mole to appear in one of the squares, I just need to add the style called mole. With this, you can see that the image we added earlier has appeared. If I wanted to add this mole to the last of the squares, I'm going to add this style called mole. We see this image again. This is how we will be able to modify or establish that a mole appears in each of the game squares. This is what we will do next. I'm going to stop the app execution once more. I'm going to go to the main game file, that is, where we declared the HTML code of the video game. In this part where we are adding each of the squares to the game, I'm going to indicate that I want to add an event called onMouseUp. This event will be triggered when we click on each of the squares. This will help us identify when we have clicked on one of the squares and know if we have hit the current mole or not. We will indicate that this event will be associated with a method called mouseUp, which we have not yet created. Let's pass a reference of the current model to know if that's the square where the mole is located. We're going to define this method called mouseUp through the code section. Within these brackets, I want to create a private method called mouseUp that doesn't return anything, to which we will pass a square model. Here, we're going to ask if the game is running. We see that we have an error because I forgot to specify a boolean field called isGameRunning, which is equal to true by default. This field will help us know exactly if the game is running or not. I'm going to change the name of this field, and here we can specify the logic. If the game is being executed, we're going to ask if the model ID is equal to hit position. Then we're going to accumulate a score value of 1. What we're doing here is identifying if the square's ID is equal to hit position. Hit position is that field where we're going to store the square in which the mole currently appears. So, if these values match, we're going to increase the score by 1. You might wonder how this field called hit position is selected. How is this value set? Well, that's what we're going to do next. To perform this method, we're going to create a couple of additional private fields. The first one will be of type random, called random, and will be equal to a new instance of the random class. We will also indicate that we want a number, a property or an integer field called last position, which is equal to null. This field will help us know the last position where the mole appeared, and not repeat that same position so that the mole always changes its location. Next, we will create a new method that returns nothing, called setNextAppearance. As part of this method, we will create a for each with a var item in squares, which is the list of square models, to go through each of the elements that are part of the game. What we're going to do is assign isShown equal to false to disappear any mole that may appear as part of the game. That is, set the game in an initial mode. Then we will declare a variable called randomPosition. Next, we will create a do-while loop and assign to the property called randomPosition the value of random.next to select a random value between 0 and 8. This will be executed while last position is equal to randomPosition. With this, we will ensure that we always have a unique value, since if the value were repeated, the mole would simply get stuck in one place. What we want is to achieve that every time an iteration of this type occurs, the mole moves to a different place. Once we get the random value, we will access the property called squares. We will access the unique random value we obtained earlier and assign the property isShown equal to true. Let's add that additional style so that a mole appears in the specified position. We will also assign the value of randomPosition to hitPosition to know the last value that has been assigned. In addition, we will assign the value of randomPosition to last position, with the aim to knowing in the next iteration what that last value we have obtained is. Finally, we will invoke the stateHasChanged method with the purpose of notifying the graphical interface that some change has occurred and somehow forcing the graphical interface to update. We have declared this method that will allow us to assign that appearance of the mole. The next step is to create timers so that we can start the game, control the game flow, and specify how fast different moles will appear. We will do this by creating a couple of timers at the beginning of the code section. We will create a first timer of the periodic time type called GameLoopTimer and a second timer called GameTimeTimer. To manipulate this pair of timers, we will create a first method that allows us to control the appearance speed of each of the moles. We will create an asynchronous method that returns a task called GameLoopAsync. We will indicate that we need to pass an instance of a periodic timer called timer. Next, we will indicate that while the game is being executed, we will call the setNextAppearance method and also await timer.waitForNextTickAsync. A new mole will be invoked to appear on the graphical interface. The specified time as part of this timer will be waited for this method to be executed again. We will create a new asynchronous method called GameTimeAsync, passing again a periodic timer called timer. Within this method, we will indicate that while the game is being executed, current time will decrease. If current time is equal to 0, message will be equal to game ended. In addition, isGameRunning will be equal to false. We will force a graphical interface update through stateHasChanged. We will invoke timer.waitForNextTickAsync to wait for the specified time of the timer, and the execution of all this code will be carried out again. Now it's time to initialize the game to be able to execute these timers. We will override the onInitialized method. As part of this method, we will initialize the timer called GameLoopTimer to be equal to a new periodic timer. We will initialize the periodic timer using timespan to specify the duration of the timer. Let's use the fromMilliseconds method and also use a field called GameSpeed, which is a field specified earlier. Finally, we initialize or invoke the execution of this timer through an underscore, which should be equal to GameLoopAsync, passing GameLoopTimer. Here we can see an error, as I made a mistake in the naming of the method. It should be GameLoopAsync. With this, we have completed this part for the creation of the timer, which is the timer that will be in charge of the appearance of the moles. We are indicating how fast each of the moles will appear. We can modify this field as we want, and with this, the execution of this timer will begin. I will copy this code to initialize the second timer, which is called GameTimer. We will indicate that it will use initialization through timespan.fromSeconds, passing the parameter 1. This is because since we want the game to have a duration in seconds, for this timer to execute every second, we have to initialize it to execute every 1 second. We will invoke the method called GameTimeAsync. Here I am missing a C, in fact also in the creation of this method. And we will pass GameTimer as a reference. With this, we will trigger this second timer to perform a certain action. With this, the game should already work, at least in its basic form. Let's start the application. You can see that we already have the mole appearing here every now and then. We have control of the remaining time in seconds. This figure appears every certain time. I'm going to stop the application execution. I go back to the variables section and I'm going to modify these variables a bit so that the game duration is 60 seconds and the mole appears every 500 milliseconds, that is, every half second. I start the application execution once more. You can see that the mole now appears more quickly. Let's see if we can click on it. You can see that every time I click on the mole, the game score increases by 1. With this, our application is working correctly. The next step is to improve the graphical interface part, as the visual appearance is not very attractive yet. To do this, I will go back to Visual Studio. I'm on a site called Gradient Magic, which is this one you can see on screen. I have previously found a collection called Carbon Fiber. I have these two styles that I quite like. I'm going to use one of them, for example, the first one. To change this part of the graphical interface, I go back to app.css. I'm going to go to the main part of the application, which is this element called main. And to apply this background, we simply have to paste what we copied earlier. I'm going to save the changes, I start the application execution, and now we can see the application with a quite different background. The next step we're going to take is to change the font of the application. To do this, I'm going to open a new tab in Google. Let's search for a font called Fredoka. We find it on Google Fonts immediately. Once we are on the Google Fonts site, I will select the regular font. I click on Select. I click on this option that says Add Import, as I'm going to copy this line that is between the style tag. Once I have done this, I return to Visual Studio and I will paste this line that I have copied at the beginning of the app.css file. I will save the changes. To apply this font to all H1 and H2 elements, I will select these two tags, indicating that I want a white color for this font or for these elements. Then I indicate font family, I will specify that I want to use the Fredoka font, and if it is not found, I will use a default font called, or a font by default, sans serif. With this change we have made, I will start the application to see how these changes look. You can already see that the font has changed considerably. The next step we're going to take is to add a glow effect for this font family. So I will return to Visual Studio, to the app.css file. After these two definitions, I will indicate that I want to modify the H1 element independently, with a font size equal to 3 EM. I will also indicate that I want a margin so that this tag does not take up so much space of 20 pixels. And I will also apply an auto margin so that the content of this H1 element is centered. I'm going to indicate that I also want a shadow. I will indicate the numbers 005 pixels. The color we will use is color 80080. I can duplicate this assignment I have made, so I don't have to write everything again. For this second section, I'm going to indicate that I want to apply 10 pixels to the final value. I'll keep the same color. I'm going to add this element once more. Only this time I'm going to indicate that I want a value of 20 pixels, and I'm going to leave this last value. That is, I have 3 sections, the first with 5 pixels, the second with 10 pixels, and the third with 20 pixels. With this change I've made, let's see how the application looks. Done! We have this effect that looks pretty good, with the background we've applied as well. The next step is to center the elements that are currently in a column format. They need to be placed in a horizontal format. For this, I go back to the app.css file, and what I'm going to do is modify or create an element, or rather the style info container. I'm going to indicate that I want to align the elements centered. I want a flex display. And finally, a justify content equal to space between, so that the elements are distributed evenly. I save the changes, and you can already see that the elements are being placed in a better way. The next step is to change this background for our board, since we currently have a single color. It looks good, but a gradient would look better. Previously, I searched on the gradient site that I showed you earlier. A gradient is this one that goes from a dark purple to a lighter purple. I'm going to copy the CSS code. I go back to Visual Studio to the CSS file. I head to the board class, which is this one we see here. I'm going to paste this background image. I save the changes, and you can now see the color applied successfully. We can make some additional adjustments, such as adding a rounded edge to this board. We're going to indicate that we want a border radius of 15 pixels. We save the changes, and the board looks much better. The next thing we're going to do is add a pulsing effect so that a type of animation starts when we hover over the board. We can do this immediately after this definition of the board class. I'm going to indicate board when I hover over the board. This animation is called pulse. We will create it later. It should last 1.5 seconds and be executed infinitely. We're going to create this animation using the add keyframes. It's going to be called pulse. We're going to indicate that the initial value is 0%, the final value is 100%. We're going to create here, or we're going to indicate that the box shadow will be equal to 0, space 0, 5 pixels, and a color B77EFC. I'm going to copy this line. I'm going to replace the value of 100, but instead of 0, 0, 5 pixels. I'm going to indicate 0, 0, 20 pixels. It's going to be the same color. Next, I'm going to declare a second section with the values 0, 0, 30 pixels. The same color I added earlier, which is this one. Finally, I'm going to declare one last section that is equal to 40 pixels and the same color. This is to have a box shadow according to those values I specified. I save the changes. If we go back to the game, we can see that we now have this pulsing effect that looks pretty good. It animates as soon as we position ourselves over the board. What other things can we do? We can also add a rounding to each of these spaces where the mole appears. And we're going to do this by going to the style called square, which is this section we see here. We're going to indicate that we want to add a border radius equal to 5 pixels. We save the changes. This looks much better. We're also going to change the cursor type so that a different cursor appears when we're over each of these spaces. Let the cursor be equal to pointer. Now with this, when we enter each of the squares, notice how the cursor changes automatically. We're also going to add an animation so that each time we hover over one of these squares, we have an animation to know where we are. We're going to do this through transition, background color. We indicate that the animation will last 0.3 seconds and have an ease effect. The next step is to specify when this animation will occur. We will do this through square, hover. We are indicating that when hovering over any of these squares, an animation will take place that will change the background color to EAB9FA. If we save the changes, we can see that when entering each of the squares, we have a nice animation that looks quite good. The last step we're going to take is to animate the appearance of the mole element. Currently, if we start running the application, you can see that the mole appears immediately. We will add one last animation for a better effect. We go back to the styles file and we will modify the style mole. It's the one we see here. We will indicate that we want an animation called pop in, lasting 0.3 seconds, with an ease out effect and forwards. Once this is done, we will define the pop in animation that we will use. The animation at the 0% value will have an opacity of 0, meaning it will not appear visually. The transformation will be equal to a scaling of 0, meaning the element will not appear at all. To achieve an animation or an effect that makes the mole appear, we will indicate that when reaching the 100% value, it has an opacity with a value of 1. In addition, a transformation with a scaling value of 1, meaning it returns to its normal state. We save the changes and start running the application again. With this, we can see that the mole appears in a better way as part of our game. We can now play the video game as many times as we want. In case we want to increase the game speed, we simply need to modify the Blazor SMAC file and change this property of the game speed field. We can set it to a value of 250, which will make the mole appear faster. With this, we have finished creating our game. We can also install this application. Since we selected the option for it to be a PWA, we can click on this icon, which allows us to install the Blazor SMAC application as if it were an operating system application. Let's install it. Now you can see that we have our application here, which looks pretty good and can be run as many times as we want. We have finished this tutorial. I hope you liked it and found it helpful. Let me know in the comments what you liked the most about this game and what is your highest score once you have finished it. I invite you to like this video, subscribe to the channel and click on the notification bell so that you are informed as soon as I upload new videos related to development with .NET. See you in the next video.